VNIT Nagpur. His research interests span across several cutting-edge areas, including AI applications in power systems, deregulated power systems, energy trading and energy management, smart homes, energy forecasting, renewable energy integration. With over 20 years of experience, Dr. Altaf Badr has made significant contributions to the field. He serves as an editorial member of multiple international journals and has supervised two PhD scholars. His research output is commendable with over 50 publications in international journals and conferences. Beyond publishing, he has actively contributed to the academic community by chairing numerous conferences and delivering more than 50 expert lectures. Additionally, he has authored 9 book chapters and 2 books. Dr. Altaf Badr is also a Board of Studies member in 3 engineering colleges, playing a key role in shaping academic curricula. His leadership in organizing academic events is evident from his successful coordination of a conference and a previous Gian course. The ongoing Gian course on the Internet of Things and Predictive Control is another testament to his dedication. With that, I now invite Dr. Altaf Badr to proceed with his session for today and share his valuable insights with us. Thank you.
Yeah, thank you very much. To be very frank, I have also worked as a freelance programmer for 4 years. So, I am more so attracted towards programming as a hobby. And IoT gives us a idea like it's a combination between programming as well as electrical if I combine it. So, the fundamental is what I have learned over a period of time is whenever you are teaching, one thing that I do more stress on is it is better that the person sitting on the other side learn on their own. Self-study is far better than as compared to giving spoon feeding part. So what we will do today is basically the sessions are divided into 2 parts. The first part would be just an intro to the IoT part, and actually we were going to have a case study in the second half, but I wanted some hands-on session on Arduino, so we have added Arduino programming into the course, and we'll have it in the second half for that. So today we'll start with introduction to IoT, and then we'll move a short introduction, because as far as I do understand, majority of the people have an idea as to what IoT is, and that is why they have opted for it. So basically what we will do is we'll have a short intro to IoT, and please keep it in mind, like it's not a comprehensive course. I have considered like we will basically take it to a smaller level. The higher parts would be left for you to explore, but we would touch the places which you can explore, and we will also touch the resources which are available, so that even when you are out of this, because 5 days is not going to make you an expert. To be very frank, I would say nobody is an expert in any field nowadays, because the changes are too fast, and it's impossible to master a skill in today's date. Whatever you say, you will find another person who's at a better position than you. So what we can do is we can just share our knowledge, whatever we have, and we can explore the possibilities of utilization of IoT in different places of our research. Now basically, is it moving? Yes. So basically, let me start with an intro to NIT Warangal. It was established in 1959. It is one of the oldest NITs, and right now we are ranked at 21 for around 2 years now, and as university we are ranked at 53 again for last 2 years. We have been hovering around 19th rank to around 23rd rank, so average is still 21. In THE ranking for Asia, we are in 351 to 400, and worldwide we are there. And we have got around 310 plus faculties across 13 departments with 7,000 students in place. These students are from outside India as well. In fact, one of my PhD scholars was from Ethiopia. So that is how it works here. It's still developing. We are still evolving, and hopefully we'll progress very fast. So I'll start with what is IoT, and I would also like to have some interactive sessions so that you will also not go to sleep. So and not make it very serious. It's a interaction which should actually be aimed to create connections and bridges so that we can continue this work further. So basically what I do is, usually whenever I start with any topic, there are 2 to 3 things that we should always think about. One is the definition of it. So Internet of Things, the definition is given as Internet of Things describes devices with sensors, processing ability, software and other technologies that connect and exchange data with other devices, etc. I basically go to Wikipedia first, because that is where my students will also go. Actually, it's in today's date, it's a fight between teachers and students, who's more technically advanced. So I have to show that yes, I am also using your techniques. So that is why usually I'll go to Wikipedia first to get the reference, and it probably defines all the things. But if we just think about it, why are we using IoT is basically to collect the data and transfer it. So for most of the applications that I went into and tried to look into, this is the majority places which I could find. But then I found one case study which we'll study also, where we will see that even analysis and processing is compulsorily required, without which it does not make sense. Plus IoT is like collection of data. That is what we already know. So I consider it as 2-part system, where the front end is probably IoT, hanging on with its reference, its sensors and all the collection mechanism that it has. And then on the back end, we have got the data storage, we have got the processing of it, and the analysis of the data. See, ultimately, this would lead to something called as big data, which was way back a keyword, years back it was a keyword. Now nobody uses it, because now those other terms have come in, like data scientists and data analysts and all of it. But to be very frank, I believe majority of us are from electrical engineering, and we do understand that electrical engineers were handling big data from years before, because the amount of data that is generated is huge. If you just go to the information related to the load flow, which I usually work on in a huge way. So if you just go into load flow, you will find that we are generating a huge amount of data that is there. And this is going to further increase like anything. This is going to go exponential now. Because what has happened is that not only is the power system expanding, but there are complexities coming into that. Around 10 years back, there was, hardly some people had some solar rooftops, wind, this, that, whatever it is. But now, and with the government pushing into it, giving subsidies into it, we find that everybody can now install solar plants on their rooftop. So just imagine the amount of data that we create into that is humongous. And this is only just one part of it, because that data you are able to access. If the utility also gets it on a minuscule basis, that how much each guy is generating, that would lead to a huge amount of information that would be there only because of solar. In fact, at one of the places I heard that in 2010 I'm talking about, Texas, probably the population is quite less than majority of the states in India, generated around 10 TB of data just because of smart meters. So this is a humongous information that you have, and this qualifies into the big data category where it is very tough to handle it. Now what happens is that with I'll just give you some more examples also, because that is also necessary. EVs will also come in now, with we assuming that majority of the vehicles which would be registered by 2030, this is the government commitment and probably we will achieve it, majority would be electric vehicles. Now if electric vehicles come in, let us assume that we 19 people or 20 people are sitting here, out of us let us say 15 people have got an EV, majority of us will go home by 6 to 8 somewhere and we'll plug on the EV. Each EV, if it goes to, on the normal side, 3 kW, you can just imagine the load that will increase suddenly in the evening part. So we need to control that also. There are many other things that have to be taken into consideration. Now when I'm talking of huge amount of data, there is one more aspect that is very important that we should look into, and that is the WAMS, Wide Area Monitoring System, in those who are not familiar with it. Now this wide area monitoring system employs something called as PMUs, that is phasor measurement units, and these elements generate data at a very fast pace and you have to collect it. Now for all the non-electrical engineers, just try and understand, at every moment in time we have to manage this equation where we say that PG is equals to PD plus PL, that is the total generation is equals to the total load plus the losses. This has to be maintained in any cost, right? And we need to run a load flow which is iterative in nature, and we need to get the answers. Now if you just see the geography of India and the amount of electric network that we have, if you have ever attended any of the Grid India presentations, you will find they give you kilometers of transmission line that India has, and that goes into millions of kilometers. So we basically have to analyze all of it, run over it, and give the results within fractions of second. So that is a tough task. Plus, as far as I do have understood through different interactions, what I understand is we are not moving towards the microgrid concept, which goes for smaller units of grids, but we are actually moving towards something like super grid, where we are also inducting other countries into the grid. Now this will further have issues for management and all of it, but anyways we are not going into that. I'll stick to the big data part. So IoT's back part would be the big data which you need to handle. So the best example is, we buy fruits and all of it and vegetables and we put it into the refrigerator, but if you don't take it out, the whole things that you put into the refrigerator is a wastage. So all of the data that we are generating, if it is not analyzed and processed, it will go into wastage. So anyways, we will not discuss how this processing happens, but I would suggest again that when you have free time and when you are back to your place, you go through something called as big data. There are free courses available online, even on NPTEL and all of it. Big data courses are available. Go through it to just have an idea, because if you have studied IoT and you haven't studied big data, probably it will not be helpful to you. So go through it. Then I would like to just go through in brief the history of it. Again, this is a little bit contradictory when we go from source to source. Anyways, history will not affect how it is going to happen, but just to have an idea as to how it works. Around in 1960s and 70s, there were some early concepts that came in, and that is where the fundamental of it started. So there is something called as ARPANET that was a precursor, was developed in this duration. And then as we go towards 1980s and 1990s, as far as I do know, in India we still did not have internet in a full-fledged way at that time. but there were some protocols which were being developed and standardized over a period of time to enable proper communication between the devices. So even the net had come into place at that time, and in 1999 it is said that the term Internet of Things was coined, and by 2000s basically IoT had taken shape, and there were some this RFID cards which tags which had come into place by that time. And at one of the resources which I read, it said that by 2000s the number of internet connected devices had surpassed the world's population. This is one of the things which we'll see in the coming slides also. This is probably from the computer science department, that they usually show as to how many devices and how many humans are connected to the net. So what we saw was, like in 2010 around, there was a rapid growth and development, and I believe that by this time approximately a huge population in India also had got smartphones. Around 2000 to 2005 India saw that there was a lot of phones, not smartphones I would say, but a lot of phones coming in, so it was costly. Many of the people sitting here are research scholars, probably they might not have seen this phase, but we used to pay money to go and use internet in a cafe. It was not available in your phones and laptops. In fact, laptops was I don't think I had seen a laptop by then. So the thing was, like, it was a little bit costly at that time, and then around probably in Europe at that time, now there were some smart home devices that were coming in. Again, one of the very good examples for those who want to explore IoT is smart home management also. I had worked for some time on that part, but then finally I had to drop it out because you cannot travel in multiple boats. So smart homes are also a good topic if you want to explore later on. Now by 2020s, the time when we are in, we saw something like 5G networks coming in. In fact, now China, and they are already moving ahead and they are going with newer technologies. Ultimately, when you are studying IoT, it's a multiple perspective. You have to study communication as well. Without that, it will not work. So you need to study that part also. So then now there were some other concepts that had coming, like fog computing and edge computing. I'll cover that also if possible today. And then now one important thing that comes in, see, the fundamental is, in a class we don't get a feel of the things that are actually happening on the ground, but we should at least put it into our minds, and then when we are actually applying it, then we see it. When we go to the lab, when we go to the field, we see that no, this is wrong, this is wrong. And the best part is, I also teach Python programming in electrical engineering. The best part is you have to question. Till you don't question, you cannot learn. If you just follow what has been said, then it's like a repetitive task that you are performing again and again and again. But if you question the things, then there is a chance that you come up with some newer solutions. You come up with, in fact, newer problems also. So with this happening, there is another issue that came in by 2020s, and that is the standardization of the system. And why standardization is required is, one of the major reasons is security. Nowadays, we make a call, and before you are connected, there is a message from the Ministry of Ministry of Home Affairs, which says that beware of the fraud calls. In fact, even after getting so many messages, we are still, there are chances that we get duped. In fact, I got a call 2 days back also. So, and I picked it up. I thought it is one of the participants, and I picked it up, and I was in a hurry, and he said, there's something has come from the police station, and I said, you please take care, and I just kept it. Then after 1 hour, I realized that it might be a, scam. But then it was already too late. I blocked it and all of it done. But the thing is, security is important. So in IoT, what is happening is communication will happen. And in communication, there are two basic things which I have learned over a period of. One is intentional hacking that may happen. The other one is by chance that may happen. So in both the cases, standardization will help us to overcome the problem. I believe everybody would have studied that, parity check and all of it. So those are just the starting part of it. Then there are other things, and obviously in IoT we use multiple different methodologies for that thing also. In fact, I had conducted one session also for that, as to how for our students as to how the security can work out. So if possible, we'll try and go into that. Now, as I said, there's a very good part into this, that usually the devices and the humans are compared. So first ATM came in 1967. Probably it was not here, but it came. And then you had, by 2008, there were more devices on the net versus the humans. Now, what has happened is, this will keep on increasing. And the reason is, what I have seen over a period of time is that, your shirt would be also an IoT device, your specs would be IoT device, your shoes would be IoT device. Now, as a power system engineer, still okay, but I don't know how others would be able to manage it. This is too much of data to handle. In fact, if you all have observed it, around 1 hour at least goes to remove the unwanted communication in our phones. We are used to it now. That is where I started with. We are already used to it. In fact, I recently attended one of the conferences, and now they have also integrated the social media information about the power system also. So they are capable of doing it. I'll give you one, example is like electrical engineers are, I think so, they are very versatile, especially those who are working on the ground. I won't count myself into that, but those who are working on the ground, the power grid people and all of it, they are really very versatile. They have to forecast the data, they have to run all the things, and they do it fantastically well. If you see over a period of time, those who would agree with me, we had a lot of power cuts earlier. Now, at least we don't see it here. If it is also there, it's like, a small period of time that we have a power cut for. So things are changing for the better, and with technology we should be able to handle it. The only thing is, at one place I read that technology is like a matchstick. It can burn a candle also and light the place, and it can also burn a house also. So how do we use it? It is up to us. And one more thing is, we need to protect the candle also. If we have lightened the candle, we have to protect it, because there are people who would want to just use it for burning of the house. So technology will obviously be going ahead, and we need to take care for it. But anyways, ma'am, I'll just come to you. If more devices are coming in, it will not be, maybe the loop may increase, but we are already handling it. So there are places. Actually, what happens is, I'll tell you, like PMU came in. I just mentioned PMU. PMU was very costly. So if you go to the time period of 2010 to 2015, there were researches done on how the PMU should be placed. Where should it be placed? Because it is costly. You cannot put it everywhere. The other way around now is that the costs have gone down. So we are putting it everywhere. Similarly, it happened with the batteries also. So if I put batteries into the database also, initially they were very costly. In fact, around, again in 2012 or somewhere, I had gone for a quotation, and half of the cost was for batteries and half of the cost was solar panel. Nowadays, it's not like that. So the things have changed, and what happens in power system is, when it is costly, we start integrating it. So when the numbers increase, we have to just increase the number of loops. That is it. And probably, I'm not very familiar, but I think so with parallel computing, we can achieve those things. So then, by 2015, we had around 5 billion connected devices and 6 billion smartphones. Now, I assume, I do give some time every day, to some technical part also. So now, this is in 2015. However, I would suggest that if you go by 2024, from now onwards, last year onwards, after the advent of ChatGPT and now DeepSeek and all of it, things would change dramatically now from here. See, in COVID, we saw something which we had never seen. Nobody thought about taking classes from home. Not only taking classes, we took exams also from home. And we made sure that the students did not cheat at that time. We tried to make it sure. Now it has become a norm. I met the foreign faculty also, whatever way you meet him, but then after that to build a structure, you have to have meetings online and all of it. So now Google Meet has become a norm. It's like a normal thing. Many a times it happens that you are sitting in one faculty room, other guy is sitting in another faculty room, and we are still in the same Google Meet. We don't go and physically meet. So things are changing, but my personal thought process is that this would change in a big way in the next, by 2030 the world would be totally different. Because now, yesterday itself I heard something called as agentic AI now. And they say that it would leave around 30% of the jobs immediately redundant. That's a huge thing. And if they are speaking about it, I believe in the next 6 to 7 months or maximum 1 year, we would be seeing something like agentic AI. And what it is you just tell that thing that I want to set up a business on this thing, and it will do everything for you. It will even take your credit card details, pay for it, analyze the data that is coming, reconfigure the things, again do it properly, and in 48 hours it will give you a full report whether your business is feasible or not. In fact, I can take up a website and say that you create a replica of this website and it will do it. So website designers out of business, business analytics out of business, social media content providers out of business, and a lot of things. Fortunately, we may not go out as electrical engineers. I'm not sure about it, but fingers crossed. And the bigger parts, it also creates social media content on its own. So yesterday I saw something like, I'm going a little bit out, but it will engage. It's a good thing that you also know these things. 2 days back I saw something like ChatGPT can write poems. Yesterday, just before we started, I was in roaming around making arrangements and all of it. So I had some time. I said, let me try in ChatGPT whether it can write a poem or not. And it did write very well. I think it was better than what I could try on my own. So poets also out of business. Let's see what happens further. Anyway, so then now by 2020, this is still an old data. This is 2024. We had more than 50 billion connected devices. Now connected devices does not mean people. These are which are automatically connected with the internet. This has got nothing to do with humans getting connected, right? It's not like when I use my mobile phone, it is counted as humans getting connected. But when there are devices which automatically get connected, that is what is counted here. Like if you have got a GPS on your car and it automatically is getting tracked, which will happen very soon, I assume, then that is your connected device. Your car is a connected device into that. So this is another data which I got, and the reference is given down there. If you see again how many billions of devices were connected, and by 2020 it gives the figure of 50.1 billion here. I'm not sure if you see here, it's 15.1 billion, and the curve is exponential. So you can just imagine what will further come in. So the thing is, anyways, this is not that important, but the point that I'm trying to make from the beginning is like, more devices, more data, more information, and humans cannot handle this much now. So going by the doomsday, let us come to now how we can use technology for our own benefit. That is more so important. Just give me a sec. Yeah. So then we go to something called as IoT variations. Variations in the sense is, when I initially went and started searching for IoT, it was all okay, fine. But then as I went into that, I found that Internet of Internet of Things is already old. It is already divided into different parts now. And what we do is that how it is tailored for different areas comes into that part. So now we have got some specialized things like consumer IoT is there, right? So with consumer IoT, what are we thinking of is like, refers to those IoT devices which are designed for some personal uses or for home use or something like that. That will go into the consumer IoT part. So what are the fundamentals here is, it is going to help me improve my lifestyle. I don't know whether it does or not, but the convenience would be improved. One of the examples I'll give you, there is a dustbin which is being used in, I think so, Google Home or Microsoft Home, I am not sure about it. And this dustbin has got a barcode reader kind of a thing. So if you have used milk and you throw that milk packet into that, it will automatically order another milk packet and it will be delivered to your house. So you need not do anything in that. So these kinds of things would be there. And then there are, smart home devices, like you have got smart thermostats. Anybody who has heard about this? These are basically used. Yes, exactly. This is for AC and all of it, you will have it. And then you have got smart lighting. Everybody has heard about it. In fact, in our biotech department, it is installed. You go to the toilet and it automatically starts. The light automatically starts. And then you have got smart locks as well. So lot of things coming in. And then in wearables, I need not tell you, I have already got smartwatches and fitness trackers and all of it. And then you have got, smart ovens coming in. In fact, I have heard some smart plugs have also been brought in by some of the researchers, so that is also there. And then you have got, even in consumer IoT, we can count like, those Alexa and this and that, all those things which can help me out in the working. And then another one is industrial IoT. Now this has been actually introduced as a full-fledged subject in many of the syllabus I have seen. Industrial IoT is taken up as a full-fledged subject with Industry 4.0 as a basis for that. Just a second. So basically this is now termed as IIoT, and it basically focuses on the industrial processes that are there. So there is another term that is now brought in. I'll go to that term later on in the slides. That is called as M2M. That is machine to machine communication also. So that machine to machine communication is also going to play a part in this IIoT as well. So as I said, it will basically move into something like, Industry 4.0, and it will have sensors for production lines. We already had been using PLCs and all of it. I assume everybody understands that is programmable logic controllers, and that is used for, if you are having a jam bottle factory or something, automatically the jam would be filled, sealed, and everything done. That is automation. But then now there are smart factories also which will come in, which will be able to actually self-monitor itself, right? And as yesterday our director sir said that predictive maintenance, whole 1 hour onto that predictive maintenance, but we'll keep it short. So there are a lot of things that may happen. In fact, I heard in Korea, I'm not sure about it, but they have kept like 40% now for robots. So in a factory, you can have 40% of the work done by the robots. In fact, they are making a, compulsory part to that, as far as I do know. So this would be a different scenario altogether then. So predictive maintenance, I think so all those who are sitting as research scholars, this is a really good, topic that you can expand into, and especially using IoT. Predictive maintenance is far more required than, capital investment. Usually what happens is, 2-3 days back I was talking with someone from the hall only, I don't know, and we said, investment is done, but maintenance is a problem, isn't it? Maintenance is a big issue. But if I know that this thing is going to go bad beforehand itself, I can go with predictive maintenance, and usually predictive maintenance will be less costly as compared to when the things have gone down. You can take an example of a bike you have. If you keep it, if you get it serviced from time to time, the chances of it going down is far less as compared to if you wait for it to go down. So that is where predictive maintenance comes in, and why I am putting more stress into this is when we go to the power industry, especially the transmission side and the generation side, the equipments are too costly to replace, and to have an extra standby also is a big issue. So it is better that we go with predictive maintenance. It's not the cost of a car also, they are more costlier than that. And the problem is not ending there. If let us say a power transformer goes down, getting another power transformer and replacing it is a big issue. At one point of time, I was looking after some maintenance issues in some institution. The fuse that we used was this big. The cost of that fuse was 7,000 rupees, and it was available only in Bangalore. So we had to get it from there. Every time rains came in, because I had just taken over, so I did not know that part. Rains came in, the snakes would climb there, it would get short circuited, the fuse is gone. For at one point of time, we had to wait for 7 days to get the electricity back, because till the fuse is not there, we cannot move ahead. So if we cannot move ahead, you are gone till you don't have the equipment. If we go with some predictive part of it, it is far more easier. So that is where it will come in. And then there is one more thing, like connected logistics. I personally feel Japanese are quite ahead into this. They have got the supply chains which are monitored properly, and real-time tracking is done of majority of the things. Some of it you are also you might be seeing when you order in Amazon and Flipkart. It is they'll tell you. Even nowadays in our place, if you order the gas also, you can easily see when and where it will be delivered. So that is also there, but that is that part does not come in industrial IoT. This is for their industrial part. They have ordered raw material, where is it, how much of it, tracking of it. In fact, nowadays asset management is also one of the very important tasks which is there, because again, as I said, we have invested money, but is it being utilized or not? So that is also looked into. And then industrial energy management is also one of the cases. Let me go to the next one, that is commercial IoT now. So this applies to business sectors and public sector organizations to improve the operational efficiency and, mark my words, customer experiences, along with service delivery and all of it that you can count. Experience is now very important. Indian market is now moving not from the raw things. Around 2 months back, we had a presentation from one of the professors from I don't remember the university, but he said, earlier you buy coffees, you buy coffee beans, you can grind it, use it in your home. Then the sachets started coming in. So the coffee beans were less costly, sachets became more costlier. Then that coffee stalls came in. So now you can go there and buy coffee and eat it. And then now there is something called a Starbucks and all of it. Now you have got to pay 450 rupees for that same coffee, which you could have had at your home. So what are they selling is basically the experience that you feel. So, I'll tell you, there are two places which I have gone to personally here. In one place I go and I buy my things for the whole month. They scan it with a very speed and they'll give it to you. Within minutes you are out of the counter. No long lines, nothing like that. Another one you go and they are very slow. The machine itself is slow and it takes time. You're standing in a line. Next month, where are you going to go? Even if that guy is a little bit costlier, you'll go there because he's not wasting your time ultimately. So customer experience plays a huge role nowadays. And with IoT and all of it, we can streamline the things and analyze the things. Another example I'll give you, this is not related with IoT, but good experience will actually help you improve your business. In one of the studies in US, in one of the marts, big, wholesale marts, they found out that those people who were buying diapers were also buying alcohol. This is an unusual combination which was there, right? So what they did was, besides the diaper store, they put alcohol, and now their sales increased further. So whatever the reasons may be, even they could find why that happened, but if you just go by that, you can understand that if you give a good experience to the person, you get more business. So IoT can help me achieve that thing. And then there is, something called as I'll come to that later on. Let us go to something called as agricultural IoT. I'll not go into this detail. You can go to the internet and you'll find lots of huge, case studies available on this. How much of water is to be given, when the seeds are to be sown, and you can sit in your home and actually manage the whole farm according to the agricultural IoT case studies if you just go through it. So I'll not put into much time into that. Smart city IoT, again, just there's one good term that I remembered. Agricultural IoT is, also called as precision farming in many of the cases. Exactly how much is required, you just give it. When we say smart city IoT, this is a huge topic. Again, just because of its humongousness, I'll just leave it off. But, from traffic control to cameras to this to that to waste management to drain management to whatever you want, everything will be counted into the smart city IoT. In fact, even to the extent of, you can go with pollution management, and you can go with parking also. Every city has got this issue. If you see, there are some spots where parking is not possible. So this can help you get there. The next one, for all those who want to find a new topic, this can be it. Big, or you can start it as a part-time, research topic also. This has got huge applications. In fact, I have seen, youngsters coming out of BTech and starting their own startups on this. And they have excelled like anything. Because ultimately, healthcare is there to stay. Earlier, there were doctors, you go, they'll just check your pulse and tell you what is wrong with you. Now you go, before writing a first medicine, you have at least 10 to 12 tests, you have to go get those tests done. Then you come back. Then maybe they may write some medicines. It's not their fault, they have to be sure that they are not giving wrong medicines. But the thing is that if all these things are managed, you can obviously go into the details of it, maintaining the health history of a person, to wearables, to those devices which are with the doctors, to those devices which are there in the those centers, clinics. So let us say I go for some 2D echo or something like that. That report should automatically come into my account, and there should be a common account of mine all over the place. So whichever health center I go to or hospital I go to, they should be easily able to access my older history of what kind of medicines I have been using, whether I have diabetes, whether I have blood pressure, and what is my health history. Everything should be there. So this is a huge thing. Managing this for 140 crore people, just think about it. Big business. And already this is running quite well. Plus, you can extend it to having a smart hospital also, where discharge and all of it can be done automatically without the doctors being there. You can even go with something like remote monitoring and all of it. In fact, in one of the case studies, again presented in YouTube, or I don't know, I actually use a lot of references, so I have a lot of examples with me. They say that, even when a case is reported and that guy's this thing is uploaded, automatically what will happen is that in the ambulance itself, they will start treating that person. Before that guy reaches the hospital, the treatment has already started at the place. And they say that if we do this, we can save around 70% of the casualties. So that's a big thing that is there. IoT in transportation, yes. This is what we'll go for the case study, so I'll not put much into this, but this is again a good topic. Anywhere where you can generate money and business, you can go with this. So there is something called as connected cars nowadays, and then there is communication between vehicle to vehicle and communication between vehicle to anything. That is, when we have communication between vehicle to vehicle, it is called as V2V, and vehicle to anything, that would be called as V2X, I think so. So that is again a good topic. Majority of the Indian companies are right now working on this thing, and if you go by Tesla or any other thing, you need this kind of a communication. You need sensors obviously, but you need other communication also. So if two vehicles are there riding side by side, and if they can communicate, the chances of them crashing into each other is quite less. Or even coming from opposite sides, it's very less. So anyways, we'll see a different application of this into this in the coming hours. And then the topic that we do like, IoT in energy. So unfortunately I won't go into this, but you have got smart meters coming in very soon. Right now the meters that you have are probably not smart meters, right? But digital meters. Initially we had those analog meters with the disk moving around, then we have got digital meters right now, and very soon there are already pilot projects going on for smart meters. Very soon we'll be having smart meters. For the people who are not familiar with this thing, smart meters is also a really good topic, and it has got a lot of roots here and there. Command response to communicating with other devices, controlling of the load, and this and that, a lot of applications which would be there. Then you have got obviously smart grids. You might have already heard of it, so I'll not go into the details of it. And then in some cases, if you know that in Dubai and all of it, they have got huge solar farms. They are now called as solar, not plants, the solar farms are there. So with IoT, what I can do is I can check their cleaning part, I can check their orientation, I can check, and I can do whatever I want. I can easily work on it. So again, that is a very important thing. And then you have got something like, I have many, so I'll just scroll through. So then the next one is wearable IoTs, smartwatches, fitness trackers, medical ones, and all of it. Next, my favorite, the military IoT, the battlefield things, IOBT, right? And why? Again, there are two reasons here. One, in India now the private companies have gone into defense manufacturing. The second thing is, we have seen wars where IoT and communication have been implemented. So there were cases, I think so, as far as I do know, and I'm not sure about it because those sources cannot be verified, but there were cases where that dog-like robots were employed in the recent wars, and not a single one, but number of those robots were employed, and they went into the fighting while communicating with each other. So a big possibility. Plus we have seen something like drones, swarm of drones, everybody knows it. So China has displayed it like anything, and I think so some of the cases where New Year and all of those celebrations were there. And then there are some more things like smart uniforms also coming in. Maybe camouflaging may be helpful for the soldier to survive at a given time. Maybe some medicines can be put on those wearables, and when he suffers some casualty, immediately the treatment can start by the uniform itself. So there are a lot of applications that can be there. Then you have got environmental IoT. I said that this is already a part of like smart IoT, so I'll just skip it. And then infrastructure IoT for you, Mukund. So sensors embedded in bridges, buildings, wherever there is wear and tear, water management, and all of it. And two more remaining, so I'll just cover it off. One is the retail IoT. So retail IoT and consumer IoT are quite related to each other, but in retail IoT, you know, it's like about the individual stores which are there. You have got those, what do we call, shelves. In those shelves, you have put some material. As soon as those material is gone, that you can get it. So there are a lot of applications there. Again, and the last, which concerns all of us, that is IoT in education, right? So in IoT in education, can anybody now tell me, because everybody is related with us with this thing, where do we apply IoT in education? One idea is to enhance the learning experiences, obviously the learning environment, manage the resources and all of it. But other than that, what can we think of when we say that IoT can be utilized? Invigilations, very good, yes. We already have got, in classrooms, yes, we can have those things. We can even, for paper, yes. Actually, in some of the, private colleges and all of it, when it is affiliated to a university, you have to go to the university and check it. And that is a troublesome job. So this would help us a little bit, yes. We can even look for some security purposes also and all of it. I'll try to wrap up it as early as possible, because then we'll go with tea, and then again we start with the case study and we'll try to finish it off. So IoT is now, I have, as far as my study goes, it connects multiple things. So I have written some characteristics here. Maybe I may be wrong, and you can comment on it. So one is, it is connection of different persons across time, right? And obviously it will connect people with each other, and it connects location also. This is again a point where, computer science people, ECE, electrical, civil, whatever you think of, can come together. By sitting in my place, can I basically observe the working of a particular location other than this? So in medical already this is happening, but is it possible like in electrical? So if I want to do it, or even in, we just saw like military, can we have it like that as well? So connection between locations, and then obviously connection of network which will happen, and then the different kind of devices that we connect across it, and the last one is type. When I say type, basically I mean by applications, different kind of applications getting connected and enjoined with each other. So factors which I found which are used for which affect the evolution is, one is information exchange technology, which led to data transfer, which led to AI and big data, which led to monitoring devices. So this I started with this itself, that when we say that we are talking about IoT, we are talking about large data transfer, and I can keep on speaking on it, but I need to finish it off as well, because we need to go to the case study, where I would like you to, I assume everybody has a mobile, so we'll be using some mobiles to search some websites and all of it, and we'll see how it works off. So basically this is a circle kind of a thing, where the technology increases, the data transfer increases, AI big data processes are there to handle it, and then you have got the monitoring devices which will look into it. And then there is something like this is available everywhere, and this is like a difference between M2M and IoT. Why I have put this slide is, I'll share this with you. Why I have put this is because M2M is considered as a precursor to IoT in many of the references. So machine to machine communication is considered as a precursor for IoT. However, if you see here, the in M2M there is a direct communication between two machines, whereas IoT goes for a broader communication. Connectivity in M2M will be closed network, means all won't be getting the data, whereas in IoT you have got protocols. We'll see these protocols also. That is why security is more important in IoT. It's open. Wi-Fi is open. Anybody hacks it and you are gone. Then machine to machine is more simple, whereas IoT is more complex. Applications, we have got simple industrial application to M, and IoT, it can be expanded. M2M would probably be also related to small geographical areas. IoT is not like that. And second last is obviously what I've told you, and then the user interface in M2M, it's minimum. Actually, when I read it first time, I got confused. Why? But it is minimum because two machines are communicating with each other. They are already fine-tuned for doing this thing. So it's okay. The other thing is IoT, it is better adapted to handle all those things. Shabaz, we'll stop here and I'll take the case study along with this in the next one, because this goes into now the technical part. So we'll see this in the after the break. So we will start. Yeah. Right. So actually, I took a break here because I thought this is more important, and then we'll move ahead with the other things. Because introduction to IoT, without that, we cannot go into the IoT part. So the collection of data is these are basically some of the reasons and how the privacy and security is affected in IoT. So personal data collection is there already, and in IoT majority of the data is collected without the information of the user itself. This is another issue which has come in. I'll tell you, there is a big debate. There's one professor in IISc Bangalore. He's working on how the data can be bought and sold in a grid. So if I've got a solar panel on my house, the data is coming out of it. Who owns that data? Who owns that data, and who can sell it and who can buy it? Who can buy it is a different case, but who can sell it? Can the utility sell that data, or can I sell it? Who has the right over it? In fact, I had a talk with Professor LCC yesterday itself, and when they apply for a project, they have to also include the cost of data. So the data that they have in their projects is also bought. So that is another thing which is there. Then data transmission is sent between devices. It can be intercepted, encrypted. So that is another issue. Then authentication is another thing. Authentication basically, like, passwords and all of it. So weak authentication is still an issue right now. And then the updates part. Usually we have seen this thing, when a mobile gets an update, then sometimes it will crash, and there are many issues with the newer versions that come in. So there are limited updates and limitedness in the updates, and there is vulnerability with the security and all of it. Then the network insecurity itself is there. Nowadays, there is a lot of hacking going on. There were quite good cases of smart grid hacking happening at different places. In fact, there are a lot of research going on now on cyber attacks and all of it. So, and in fact, at one of the places I read, even in Telangana, they tried to have a cyber attack happening. It was, it did not have any effect, but yes, there is a chance. And then privacy breaches already are there because of that personal data collection, as I said. Now, at one point of time, I was also working on smart homes. So there are two things. One is the data control that we have, the data that we manage from a smart home. Is it intrusive or not? So when it is intrusive, in some of the European countries, they have now banned it. You cannot get the details of a house consumption. So what happens is, like, when you are using your information, they track you to the extent that whether you are charging your mobile or not, when are you using your geyser, when are you using your iron, your washing machine, everything. That too is tracked in a smart home, which is not good to some extent. In some cases you may allow it to do, but it's not, it becomes too personal. So in some cases, that is one of the cases where we need to check for private data. Security of the physical system itself, like locks and all of it, are another issue. I don't know whether this comes under IoT or not, but in one of the cases, one of my students was working on car security. So you can open the lock when you are near the car. Automatically the car lock opens. Is it secure or not? Because again, it deals with signal processing. So there were cases where you can steal a car if the key is not used. And in those cases where you are just near the car, it automatically opens. So you can steal that car by replicating the signal from the key far away when the guy is far away from the car also. And lastly, there are regulations which are required to be there in place. Still, there are people working on it. There are many committees which are working on it. But yes, IoT still lacks a little bit of it. And then the data for those who are new to IoT, these are some of the communication protocols which I could find online. Protocols are basically a set of guidelines that we need to follow. These are not rules, but guidelines that we follow to execute it. So these are the communication protocols that we have. One is ZigBee. I assume that you all are quite familiar with it, and I'll not go into it. But it is an IEEE 802.15.4 based specification suite for communication, for high level of communication. And ZigBee is also used for personal area networks with small or low power digital radios, whatever, or like for home automation and all of it. In fact, if you go through any of the research papers on home automation, ZigBee will play a huge part into that. So ZigBee is categorized as low power, low data rate, and close proximity network as well. Then the other one is the zero config that is there. I actually had made it this one. Zero config. It is, the full form is zero configuration network. This is a set of technologies that automatically creates a usable computer network based on TCP IP. I assume everybody understand what is TCP IP. When computers or networks are interconnected, or even the peripherals are connected with each other, the best part of it is that zero configuration does not need the manual intervention into that, or any special configuration servers are also not needed. So basically it works on three technologies which are at the core of it. One is automatic assignment of numeric network addresses. Usually we need to assign addresses. If you have gone through some part of it, in computers we need to assign the addresses, so that is not required. And the second thing is automatic distribution and resolution of computer host names, and automatic location of services. So services like printing, scanning, and whatever is this. Then the next one is the Z-Wave. I'm just going, this one was the first one. Second, it's not in an order because I had to arrange it, so they were not getting arranged. So I just arranged it in a way which is possible. So Z-Wave is again a wireless communication protocol that we have, and is again used for building automation only. So this is a low energy radio wave kind of a network to communicate between device and device. What you can do is, you can, obviously many people have already taken a photograph. I'll share the PPT also. What you can do is, you can just explore this later on as in what you want. Now this helps us again in controlling thermostats or lights, maybe locks and all of it. This Z-Wave is also got one more thing. It has a Z-Wave Alliance also, which is a conglomeration of around 300 companies which are involved in the evolution of this particular technology. Then the next one is Thread. This is an IPv6 based low power mesh network technology for IoT again, and it is available at means it is free of cost. So again, I won't go into it, but yes, there's some membership I think so required for Thread. Then the next one is Matter. This one, it's moving. So this is again a free of cost service that is available and used for smart homes again. The best part of it is interoperable. It is say 5 years with an AMC and all of it. After that, that AMC has now gone. So that X company now again quotes for the further continuation of an AMC, but that is costly, let us say. So I get company Y into the place for AMC. But what happens is company X, which was looking after the AMC, has installed its own equipments there. So when company Y comes in, it is not able to handle it because now the newer devices come in. So that is why interoperability plays a very important role. So in substations, there's like this new protocol called as IEC 61850. So we use that for interoperability, right? Then you have got the other one is LoRaWAN. Now this I found at huge number of resources and huge number of research papers also will mention LoRaWAN as one of the techniques that they have used. This is a radio communication technique and it uses different kind of modulation techniques. It's a long range wide area network. The full form is long range wide area network. Basically, it is an official standard of International Telecommunication Union, and it is given as ITU-TY.4480. So you can just go through it later on. The next one is LTEM, this one, and this is again found in a huge way in the research work. This is long-term evolution machine type communication. It is a low power wide area network radio communication frequency, and it is developed for machine to machine as well as IoT based communication. I'll just go a little bit faster here. Then the next one is NB-IoT. This is again a low power. Usually you will find majority of them claiming to be low power. But that is based on electronics. It's not like electrical consumption is not there. This is electronics way of saying low power. So it's probably the lower side of ours. And this NB-IoT is again a radio technology. And this is related with LTE to quite an extent. The next one, which one moved? I don't know. None of them moved. So next one I'll take it as Ginny. Ginny is basically an Apache, means it is also called as Apache River. It's a network architecture for distributed systems and it works in a modular way. It is basically related with Sun Microsystems, which had developed Java also. So that is why the name goes like that. Bluetooth, I don't think I need to explain, everybody understands it. But I would suggest, on a lighter way, just go through the history of it, why it is called as Bluetooth. So it's a very good history that is there. Just go through it. So Bluetooth, I won't go into it because I assume everybody knows it. And then there's LoWPAN. Now this is actually 6 LoWPAN. 6 is written like that. Yeah. This is an acronym for IPv6, for low power wireless personal area network. Let me go ahead. So this is communication protocols which are required. Now let us just take a very brief, actually I don't have time because the case study itself will take 1 hour and I cannot give that much. But let me just go on a brief here. What would be the process in IoT? There would be sensors in place, they would read it, some network is required so that then I put it onto the internet, and then either it will be stored there or it will be processed there, and then there would be some actions that would be sent back which needs to be executed on the ground. On a very simple way, this is how it is going to work. So these are the communication protocols that I can use on the ground side. But then I also need something like IoT platforms. So these are all the services which are there. I won't go into the details of it. You can just search it off. These are all the providers for IoT platforms. Now, majority of them we know. AWS, we already have an idea about. Google Cloud, yes, I think so. Oracle also, you might be knowing. Salesforce, I assume it has started already in India. I'm not sure about it. And Cisco IoT, we already know. IBM Watson, IBM, we have heard about it. SAP, we have heard about it. Bosch, we have heard about it. Now, in some cases, things work, which is there actually, it's also a big one, but I am not sure whether it is present in India or not. What is the job of an IoT platform? So, there are some things which it is going to do is, one is the device management and data collection, storage, and the data analysis, along with security, and lastly, it has to have some integration capabilities, because I'll have a different system on my PC. So as we see in the next, when we go to the case study, we will see that if I am running a system, I basically want the data on my PC. So which software am I using is my choice, and these platforms should be able to integrate with that thing. So there might be a number of ERPs in different businesses, so it should be able to integrate with that thing, secure the data, right, and then analyze the data as well. This analysis of data is actually helpful for the platforms itself, because that will save the space that they'll be using, and data collection and storage, obviously I said, and the device management. Then another one which I have done is like, communication technologies based on how the distances are there. So near field communication is the smaller one, Bluetooth, radio frequency, Wi-Fi, satellite is the largest one that we can see. I don't think that is required for you to write. I'll provide the PPT, there's no issues. Or yeah, at least in my case I'll okay. No, this is not that important also, so those things which are not important I'll just skip a little bit. Then there are device management platforms. Initially when I was studying this IoT, I came across this thing called as device management platforms. I could not understand exactly why it is. So then that is why I thought I'll better put a slide on that also. Device management platforms are like, I am connecting one device to the IoT. So it starts with device onboarding to connect it with that particular network. Then I go with the monitoring and control of it, software and troubleshoot, monitoring and control, and there is some updates also if it is required, it has to give. And then I have to go with software and the troubleshoot. If the device is not working, I should be able to troubleshoot what is the problem. So nowadays, I have got this network Wi-Fi connection in my house. The thing is, the connection comes from the road. So sometimes if there is a huge tanker going on, it will break the wire. The internet goes off. Before I understand that the net has gone, the company itself tells me that something is wrong at your end. Reboot your device, check it. They don't know whether the wire is broken or not. Then you check it, automatically you come to know that something is wrong. Sometimes when I go for a holiday, 2-3 days, if I'm not at home, the net is not being used. It will automatically tell me that you are not using the net. Is there any problem with our services or something like that? So these kinds of things are like, and it automatically, as far as I know, it all automatically updates the device, manages it. So somewhere down the line, I don't think there's any person sitting there and monitoring all these things. This is all automatically done through the software. And obviously security is one of the things, but this is security in terms of not physical security. This is like device authentication and other things like patch management. This I cannot go into, encryption and all of it. Threat, any kind of a threat, software or cyber attack kind of a thing. And then there is asset management as well. Asset management, I already told you, it's a big task, so we cannot consider it right now. Then there is something like device management platforms. The benefits of it. So you have got cost, obviously that helps you with it, reliability, security and scalability. So those companies which we saw earlier may also go into device management as well. So they'll provide you with this as well. So this is a simple representation of how IoT will work, right? So there are sensors which will have control, which will send the data to the control center. It will be stored in a cloud, and actuator would be there, and there would be machines which would actually implement the information coming from the control center. Then cloud computing, I'll again come back later on in the slides as if I have time, because we are running out of it, but this is how it works. You have got different kinds of elements on the field, then different kind of communication, cloud, and your control center. So your cloud computing can be of 3 parts. One is private, hybrid, public, and your computing services can be cloud, fog, edge. How many of you all do understand what is fog and what is edge? Obviously the CSE and okay. I'll come to that. So obviously those who are already involved may be knowing, but electrical, I don't think anybody knows it. Is it? Nobody? Okay, I'll come to that later on. So these are the 3 kind of services which are there. I'll come to this later on. And this is not required. I'll just scroll through. I'll come to this later on. So just give me a sec. I'll go to the other one. Let us go to the case study, because that is, that will also help you get a hold of it. I want you to also communicate and utilize some part of it. Hey. Yeah. So we'll go for a case study on fleet management system into this. In this itself, if possible, in the middle, I'll try to cover off fog and cloud. If not, at the end, obviously, I'll try to do it. So when we say fleet management system, to be very frank, I have not implemented it on the ground, but I have made all the 360-degree study on that as to what kind of equipments would be required and how they are to be utilized, what are the benefits of it, and what do we mean by fleet management system when we apply IoT to it. Now, if you just go by anything, whenever we do any kind of an activity, majority of it is derived by our intention to gain economically, right? If you just have a look at it, like y'all are sitting in this room, there are 2 reasons why you are sitting in this room. One is to gain knowledge. The second is to improve your economic condition also, because maybe this will help you improve your research. Somewhere it will impact your research, and somewhere it will help you get a promotion maybe. If it gets you, please send me a note, a thank you note. But anyways, jokes apart, the thing is that usually, even if I'm working here, if I'm standing here on a Sunday talking to you, there should be some intention of me. One is I am interested to talk to people. That is a non-economical reason. Other may be that I have got a Gian which may help me improve my bio, and which will help me get a promotion. Usually when I go to the class also, I ask the same question, why are you sitting here? The reason is very simple. The first answer that I get, and the majority of the answer that I get, is job. They have come to the class to have a job. Some people would say to gain knowledge. I said, why do you want to gain knowledge? The second answer is to improve my skills. Why do you want to improve your skills? Obviously to get a job. So ultimately it goes to getting a job. Because if I say, if you want to gain knowledge, now internet is free of cost to you. You use as much as you want. There's a lot of information available online. Why do you want to come to a class and sit there? And many a times you have to listen to somebody whom you don't want to listen to. So the thing is, why are you going through all that pain of sitting of 6 hours and this and that? You stay at home if you want to improve your knowledge and skills. And you are so much dedicated, you use internet, you use whatever it is. But the ultimate thing is they want a job. Why do you want a job? To earn money, right? And why I'm taking 2 minutes into this is because everybody who is there out also is doing for money. The guy who came with the tea, he is doing that for money. The guy who sent that person is also doing for money. Anybody and everybody is working for economic reasons, majority of them. And forget about the education sector. Maybe we are a little bit less concerned about our economic part, but any other person who's doing a business, why would he do business unless he does not get returns? He has to get returns. So this kind of a thing that we are studying today is basically for the economic gains of how already the fleet management was already happening, but how IoT can chip in and help that person improve the gains, the economic gains. And in fact, if you talk to any other person also, they may work it out. Only the proposal would be helpful for them only if they see any economic gain. I assume some faculties are also there. If you have ever applied for a project, if it is from the government side, it is okay. But if you approach any private company, will they help you? First of all, they don't want to talk to you. This is the first response that you get. In fact, in one case, the guy replied that I have closed the business. So the thing is, like, you get such rude responses. In fact, they are not ready to even share their data. Don't give me a project, okay, fine, but they are not even ready to share the data. So they are not interested with us. Why? Because they don't see any economic benefit coming to them. But if I give a proposal to a company in which I say that, see, I will improve your sales or improve your profit by 5% or even 1%, he will listen to me, 101%. He will listen to me and he will let me present myself. And if he feels like, yes, there is a benefit in this, he will put money into that. So the thing is, this is one of the case studies where we can have a look at it. Now, when we say fleet management system, this is some of the person was working on EV. This is a big topic in German side. They have got now, EV fleets. So where to charge, how much to charge, how much of a run would be there for an electric vehicle is another topic of research, but we are not going to consider it right now. Just for information purpose, I'm sharing that part. So basically, fleet means either I have got a lot of trucks which are running there, or maybe I have got 4 or 5 taxis, I have put it into Ola or whatever it is, and they are running. How do I optimally manage it? So the basic fundamental is that I want to manage the fleet and improve profits. This is my first and last objective. So it may have even the delivery cars, you can even consider those delivery people also into this, how we are going to use that. So what is the action plan? Anyways, I'll just, this is a problem with what we say, the animation side. So the first thing that I have is, in my action plan is that whichever car I have, I want to optimize the route taken by the vehicles and I want to reduce the fuel consumption. This is only one part of it. I think so. We have got faculties from software also. There is one important thing that you have to follow. One is money and one is time. If I am providing a software to somebody, if I am writing a software to somebody, not only is cost important, what is the price of the software, but how fast am I going to deliver it? That is also important. So I want to optimize my routes taken by the vehicles to reduce the fuel consumption and also add an objective to it, and that is I want to reduce my time of travel as well. So probably they'll go hand in hand. The second thing that I have is the maintenance and avoid in untimely breakdowns. I had mentioned this thing already. If the vehicle breakdowns, let us say it is running from Delhi to Hyderabad or something and it breaks down, it's a big problem for me. The truck taking tons of load moving from Delhi to Hyderabad and it breakdowns near Bhopal, let us say, how do I provide another one, transfer the material, take it, not a possibility, it's a huge problem. I will lose a lot of money. So if my vehicles are maintained properly, probably these kinds of breakdowns would be avoided. And the last thing is, I want a better monitoring system. That is what IoT is going to do there. Ultimately, in all of them is what we'll see, that this is how it works. So what I want is, the outcome is, the first thing is my operational efficiency has increased. See, there is a difference between efficiency and operational efficiency. Operational efficiency is my day-to-day working efficiency has to increase. Not only mine, but my assets also should be performing at the best, right? Let them have stress, whatever it is, but my vehicle is not going to commit suicide, sir. So it is. We were just talking outside. He said one of the Mr. Arun was also there. They said the robot committed suicide. So the vehicles will not commit suicide. They don't have their own mind. So basically, it will have a better operational efficiency. I can utilize it in a better way. In fact, I don't want to take names because we are already on air. But if you go by airlines, one of the airlines has gone ahead like anything. It has captured majority of the airspace. That day I was traveling and I just saw we were made to pass through. Our check-in, everything was done, and they gave us the boarding pass. And when we went, they stopped us suddenly. And there was a glass door, so I could see what is happening on the other side. And what I could see is that there were the passengers coming out, right? Passengers coming out, and then with us, there were pilots also standing there, air hostesses also standing there, and there were other guys with vacuum cleaners on their back standing there. As soon as these glass doors were open, those guys with vacuum cleaners, they ran inside. We walked there slowly. The pilots rushed, the air hostesses rushed inside. Hardly for a 5 minute we had a wait outside. By that time, those guys had already cleaned the aircraft. We were allowed inside, and within next 10 to 15 minutes, the flight was out. Hardly the plane might have been there in that airport for maybe 20 to 25 minutes, not more than that. Lands utilized. So even if the operator changes, utilize it. That is what we are talking about when we say operational efficiency. So beautifully managed, they won't let it stop until unless they have a bigger issue. Otherwise, it lands and it flies. Lands and flies. And as far as I have heard, I think so one pilot takes around 12 hours of work a day. So if 2 hours, if I say, it's around 6 flights a day. No, but that is for all airlines it is applied. Ah. Understood. And that is in their agreement itself. Correct, correct, correct. So they just keep it flying in the air. No, if it stops, you throw it out. Ma'am, you count the number of seats, you count the charges. There's a huge profit in each flight. You just count it out once. 40 rows, 6 passengers per row. 5,000 by that. Just count for 2 hours how much of amount you are getting. In fact, in electrical we take it otherwise. The more it runs, the better it is for us. Yes. Because if it stops, it will rust, it will do all the other things will happen. If it is running, you are checking it. The maintenance being done continuously. So you know that it is running. The checking is being done. As soon as it enters, it will do all the checking. In fact, in one of the automotives now, they have also added that card. So if it breaks down, you put that card. There's a slot. You put that slot into that, and you'll get to know what the problem is there in your car. So those kinds of things have come in. Aircrafts are far above that. So, but as such, I believe if it keeps running, it's because if it stops again, it is not about overheating, na? Because you have already stopped it for 20 minutes. You have given it rest. More than. Yes. They don't actually turn it off. Okay. Anyways, then if I have got better operational efficiency, obviously this will lead to improved customer satisfaction, and this is what we wanted. So what is the current scenario? I'm going a little bit places where it is required, I'll just go. So in the current situation, what is there is the movement of vehicles is not monitored. They probably have those registers in place. This guy is going there, that guy is going there. And then because of that, you have got wrong route selection. But nowadays I heard many of them have put GPS on their devices, on their vehicles, so you can maintain. And then there is chances of manipulation also. I don't want to discuss this. We know already this thing. And driver may be overworked. No comments right now, but yes, these are some of the topics which are there. And timely delivery and pickup may not be achieved. This is in the current scenario that we are talking about. And then the usage of the vehicle. You have got overloading, more fuel consumption would be there. This is also there, it may happen, see, if the driver is manipulative, he may add some more material, your vehicle gets overloaded. This is bad for roads also, and bad for the guy also, because the vehicle is consuming more, and there is no maintenance which is there. And ultimately what we have here is there are some other issues which are also there, like there is no data collection, or even if it is there, then it is prone to human errors. This is like prone to human errors means whatever the driver says, I agree to that, fine. And then if the data itself is not okay, analytics cannot be done. Analytics, do you know that nowadays, if you go online, there are jobs for business analytics also, and they are paid very well. Also means through remote also you can do it now. So analysis is one important issue. Then you have got, see, if you don't know what is happening, obviously there won't be any response. And the last thing is again inefficient asset management. So if a truck, I don't know how much it costs, but maybe it should be a big amount. If it is not working properly, that is where I'll lose it out. So what is my line of action is, one is the hardware installation first, software development. This is for IoT I'm talking about. I'll be installing sensors and all of it. Software development is to be done for that. Then I go for data collection. Why software installation would be required? Anybody? What kind of software? Is it IoT software or is it something else? For hardware platform. Basically, if I'm collecting the information and all of it and doing it, for that it is required. Then I want the data analysis to be done. Then the corrective action if required, and the user awareness also. User awareness means the driver should also know what is happening. So this is my line of action, where I'll first go with my hardware installation, then I go with my development of the software, collect the data, analyze it, do the corrective action, and then move ahead with it. Software development can be first also, but the only thing is, after you get the data, you exactly know what the problems would be and at what speed the data is coming and all of it. Then the next thing is, what is the hardware installation made out of? So you have got GPS trackers. I'll come to this later on. Then you have got onboard diagnostics. This is a big field actually. If you just go online and check it out, onboard diagnostics for automotives is a big field again, and there are standards and all of it available all through and through. So this is onboard diagnostics, means on the truck itself or the vehicle itself, the diagnostics should be done, right? Then some fuel level sensors and some temperature sensors. This is not the full part of IoT. This is only the sensors that we are talking about. So let us just explore. Let us say if I want to do it similarly for a house, what kind of sensors do I need? Let us say for this room, I want to go for IoT. What kind of sensors? These are for GPS tracker won't be required, but any other sensors that we may require here in the room? One is temperature, obviously. Oxygen level, very good. Oxygen level, very good. Maybe flow of pollution, illumination, very good. Flow of air or something like that. So we can have all those things. Plus, for the furniture, nobody thought about it. Is it being maintained properly or not? What has happened? Some kind of a sensor can be there. Nowadays, there are some pressure sensors which have come in. So we can utilize those also in place if required. So now what happens is when I am going for IoT platform development, we have got, let us say, different kind of vehicles which are in place, and they will be sending the information all through and through to the cloud. So now it is required for me to put what is a cloud, because if I don't tell, then you will be in still. So basically you are using Google Drive. That is also cloud kind of a thing. But this is like, when we say IoT platform development for a company, you have to pay for it. Right now for Google, you are not paying for it. After 15 GB, you will be paying money for it if you want to use it. So the company will obviously be using more than that. So it will not only pay for the space, but it will also pay for collection of data, analysis of data and all of it, and transfer of data to its own system as well, maybe through web or whatever it is. So this is cloud. Then there is something called as edge computing. Again, I'll come to that. When I come to that, those slides, I'll just scroll through faster. Edge means the system itself processes it before going to the cloud. So cloud is a bigger aspect. Edge is at device level, and fog is somewhere in between. So there might be like a collection in between, and then multiple elements will get connected to that, like a substation for electrical or load what we say, state LDCs, RLDCs, then NLDC. So you can consider state LDC as edge computing, RLDCs as fog computing, and NLDC as the cloud computing kind of a thing. So that is how it works, how the data is to move, right? And even the processing. So if there is a problem in state, LDC can manage it at its own level. It need not go to the NLDC. Maybe NLDC can be reported that this problem had occurred, but we have solved it at our own level and it has been taken care. If it is going out of hand, it will go to RLDC. But this is for hierarchy, where there is no hierarchy here. This is only, we are talking about the level at which it will work. Cloud is a centralized thing. Fog is a little bit more distributed. Edge is further distributed. So now what happens is my vehicles are flying from here to there, maybe from Nagpur to Mumbai and Delhi to Bhopal and Hyderabad to Tamil Nadu, Chennai and all of it. And what am I doing is from each and every vehicle, I am collecting information into the cloud. Once that information is collected, I will sit and analyze it. I'll get the graphs, routes and everything that is required, right? And I can exactly get the analysis of what is happening where through the platform. So even I had just put it like, if the driver is not properly utilizing it, I can find that also. And there would be a tracking happening in his or her mobile also as well, so that I can get all the information there. So that is why in the previous slides we saw that the user awareness is also necessary. Now, what would be the challenges that come into implementing for fleet management systems? One is obviously data security and privacy. So this will always be there. In any of the case study that you put, this will obviously be there. Next thing is scalability. Here scalability is a important aspect, because I put it in one vehicle, now then second one, third one, fourth one. I have 5 vehicles already with me. I buy the 6th one hopefully someday. Right now I don't have that much money, but let us say I have the 6th one also coming into the business. So it should be able to scale up easily. So that is another issue there. Then you have got data integration. It should basically be in a proper flow of it. And then you have got, obviously this will be there. You have initial cost would be included into that. And then you have got connectivity issues as well. See, if it is traveling in places where the connection is not there, I don't know what is happening at that time. I really have no idea. So that is another issue that may happen. Then device compatibility and interoperability, I have already covered it. You have got regulatory compliance also. This I won't go into details of it, but there are some rules and regulations by the governments also, so you need to follow them. That is compulsorily required. So we need to see that as well. This obviously would be there. When COVID came, people started resisting online classes and all of it, but then slowly they found that they didn't have a choice, so they fell in line. Similarly, the driver and all of it will have to be taken into confidence that this is good for us and helpful for us. And obviously there would be data overload, but as I said, if we have got proper analytical systems, it will take care of that thing. And then the maintenance of IoT would be an added burden on the system, obviously, because earlier it was not there, now it is there. So GPS trackers will be installed in each vehicle, and as it moves, it will be transferring the data onto the cloud. I may not be able to give much time to this, but let us say if it is possible. So in GPS tracker, the number one thing that it is it provides me location data of each vehicle, enables geofencing. Anybody who knows what is geofencing? It's like, a virtual boundary that you create. So you can just, it is basically a geographic boundary that you create. So basically what happens is, in geofencing, fencing means you stop somebody from coming in, or you stop somebody from going out. So you create a virtual geographic boundary by that, and if that boundary is breached, then you get a signal into that particular thing. That is geofencing. And then you have got assist in route optimization, and yes, historical trip playback. So this is obviously also there in Ola, if you see, for the consumer also. And then integrate with mapping services like Google Maps and all of it. And then you have got support theft recovery in case of vehicle theft. So this is all known. I'm just scrolling a little bit faster because majority of the things are known to us. We already. Now, what are the requirements is, one is high sensitivity for the GPS receiver, one is cellular connectivity. If the connectivity is not there, it will basically not work. You need to have battery backup, right? Because it is installed in the vehicle. If the battery supply is gone, it will not work. And then you need a tamper resisting casing also, because anything can happen. So this is one of the devices which you can just go through, that is IOTAPC G09. This is a product actually. So you can just go through. I actually had put a link here, but I don't think we have time for that. And these are the benefits that it brings you. I'll share it with you. At the bottom you have got the website for it. So this IOTAPC, basically G09, is a product. It's a device that you can actually install on the vehicle directly. And the benefits are like, it has plug and play LTE connectivity, it has got built-in accelerometer, and it has over-the-air updates. Over-the-air updates means automatically the updates are installed on it. And then you have got expandable with 10, I'm not able to see, yeah, whatever it may be, but it is expandable with the technology. This is the place, the YouTube channel where you can go and see how G09 can be installed. There are some other trackers also for GPS. One is Calamp, one is Trackemo, one is Verizon. So this is where I wanted actually to explore more time into. Unfortunately, we have run out of time, but these are some of the companies which you can also explore a little bit. Then there is something like onboard monitoring system diagnostics, which are there. So it basically monitors vehicles in real time. As sir had said yesterday, the helicopter itself should tell that I am not ready to fly. So here we'll be able to see whether the vehicles are ready to fly or not, or run or not, or whatever it is. It will detect malfunctions and emission related problems. It will store the diagnostic information for later retrieval, and standardizes the vehicle diagnostic systems across the manufacturers. This standardization is really important. Later sometime, if it is possible, I can discuss with you, but standardization, without standardization, nothing works properly. So these are all the facilities which it should provide. Right? Vehicle speed and idle control and all of it, exhaust systems, ignition systems, fuel delivery, emission control, transmission, energy management and all of it. This is the history of OBD. This is onboard diagnostics for vehicles basically. See, vehicles is a big, for all those people coming from different backgrounds, let me tell you, these companies are also recruiting in big numbers nowadays. Whether it is Mahindra, Tata, whoever, they are recruiting in big numbers now, because they have, India is progressing like never before. As such, vehicles will increase. This is one of the factors through which we can measure. People will own their own vehicles, so they have got a good option. And this onboard vehicle management is not only for fleets but individual vehicles also. It is a good option that we have. So these are some of the benefits that we see there. That is, one is early problem detection, the other one is reduced emission, and you have got easier vehicle maintenance and repair, standardized diagnostic procedures. Usually what happens is, again I'll get back to the same thing. If it is standard, it is better. You know what is to be checked first, then what is to be checked, so on and so forth. And then you have got enhanced vehicle reliability as well. So the key components that we have, one is the engine control unit. If your student gets placed, and suddenly he comes after 6 months, I have faced this thing. They suddenly talk with these terminologies, ECU. You don't understand what is an ECU, so then I have to search it out, what is an ECU and all of it. That is, engine control units are placed, and these are used for onboard diagnostics again. Then various sensors throughout the vehicle are there. Nowadays, I think so, there are 360-degree view, fuel sensors. In fact, they'll tell you how many kilometers are left before you go for a refuel. A lot of things have come in. And then you have got diagnostic connector port. This is what I was saying. This is actually now happening, and if it gets standardized, every vehicle will have to have that onboard diagnostic. In fact, some of the vehicles I saw on YouTube, which in India also has got it. So you have to just put it, connect to it, and you get what is the situation. And warning indicators like engine light and all whatever it is. So that is the things. In fact, majority of them nowadays, give you early warning anyhow. So these are some of the protocols, OBD protocols. One is ISO 9141-2, SAE, JE, JI and whatever it is. So these are some of the protocols. One is 9141-2, and then there is, I can go into detail of it, but again, then there is that SAE J1850 at the bottom, and the last one that you see is called as CAN. So this CAN is, where basically majority of the work is being concentrated into. So, this is also which is there, and then this is a repetition. So for telematics OBD, there is this company called as Samsara. Again, so you can just scroll through it, and I'll share with you. You can click on the link and it will go and open that website. So this device is quite similar to GeoTab, but other than GPS tracking, it also provides onboard diagnostics to you. So these are some of the online market surveys taken from these websites, where it shows you how handheld tools have changed, and mobile-based tools have improved, and PC-based tools and others have improved over a period of time for OBD. We are just talking about onboard diagnostics only right now. And then you have got by vehicle type, how it works basically. So year-wise, you can see how the difference has come up. For electric vehicles, how the market has changed, and other things also which are visible there. This is another aspect to that, as to how things are changing. So if you see, for passenger vehicle and commercial vehicle, it is actually around 40% increase that we can observe there. From these are two more two more websites which I have. Both are from Wikipedia, and it actually gives you a lot of information based on onboard diagnostics. That is where actually I started my lecture with that. I'll give you information, you explore it as much as possible. These are some of the websites where you can go and explore. It's a huge one actually, so I could not concise it into a slide as well. So one of it is onboard, the other one is OBD2 PIDs. OBD2 is the current one that is going on. Then you have got some fuel sensors which are required. It provides you accurate fuel data level. You will be basically managing the vehicle to the level that you will also be sitting in your place and see that what is the fuel level in a particular vehicle exactly. So this would be as many vehicles as you have, you will get it on a continuous basis. Then if there is a potential theft, you can easily detect it again through that. Assist in fuel consumption analysis, also optimization. For fuel sensors, what is required is high accuracy, compatibleness, resistant to fuel sloshing and all of it. Sloshing usually means when it moves, there would be those kinds of things will happen. The fuel will move up and down, so that should be taken care of. And it should integrate with the other things. Now in this fuel sensors, usually what I have observed is in majority of the cases they will specify that you can have a plus or minus 1% error margin, not more than that. Then we'll just skip this one. So usually it also follows certain requirements, like IP67 enclosures are also required for these kinds of things. And if you see here, there is one company, Rochester, which is there. It provides you with fuel sensors also. Now the point what I'm trying to make it is, you have got different these equipments. So if you actually want to implement it, you need to get these things, put it on place, and you will be in a position to utilize it. This is for temperature sensors and what kind of connectivity and all of it requires. So it should be able to work on different temperatures. Obviously, you go to Kashmir, the temperature levels would be different. You go to Chennai, temperature levels would be different. You go to middle of India, the temperature level would be different. It should be able to do comply with all of it. And otherwise also, nowadays you have a temperature sensor anyhow in the car, so you can just extrapolate through that. High temperatures are usually to be avoided as much as possible. However, the range if you give is minus 40 to 60 degrees. Accuracy plus minus 0.5%. Battery life should be 2 years is what we can see, and it should work on these technologies. Monet is one of the companies which again provides you with the temperature sensors there, and it claims to have a battery life of around 12 years. So you put it into that and it will keep on working. And also it claims to work in a range of minus 40 to 125 degrees centigrade. That is a huge variation in which it works. Then when we go to IoT gateway, it is used for inter-device communication and device to cloud communication, and then you have got data processing, and this we already saw, like that platforms which were there are also part of this thing as such. So you have in a gateway, you have got a sensor layer. This is the first one. Then you have got a network or data acquisition layer. Then data processing. This is also what I told you. Like you have to first sense it, acquire it, process it, and apply it. So these are the basic expectations that we have. One is collect and aggregate data, provide edge computing. Now I assume edge computing means some analysis would be done at the vehicle level itself. It will not go to the cloud. The problem does not go to the cloud. Transmit data to cloud. This is as and when required. The second one is for local data processing. If there is something that is required, it will automatically do it. Enable over the air updates. Over the air means automatically it should get updated. And requirements, multiple connectivity options should be there, powerful processor should be there, rugged design because in vehicles it will be moving here and there, and expandable storage should be there. This is again one of the gateways which is available. This is from Dell, which is there, and this can be utilized. The best part is that this particular thing works from -30 degree to 70 degree centigrade. So that is a huge thing. It has got a memory of around 2 GB, that is RAM, and a storage of around 32 GB with it. So that is a huge thing that is available with you there. It's quite powerful as well. Some of the other equipments that we may need is tablets, smartphones, cloud platform, network infrastructure, and application software. Usually this application software has to be developed at your own end. It will not be provided by anybody. So as per the requirements, you have to do that. And then we go to cloud computing. So I assume that I have already covered this thing. We'll just go a little bit faster here. So you can just go through the slide here. This is how it works. A computing model that delivers on-demand computing services over the net from remote data centers, allowing users to access and utilize these resources without direct active management, enabling scalability, flexibility, and cost efficiency. This is for cloud. In fog, what happens is it extends cloud computing by creating an intermediate layer in between the computing nodes and the end devices. So this actually helps. This is a kind of evolution that has happened. This helps bring down the load of the cloud computing thing, and it basically therefore helps in security, latency, and it is more efficient. For edge, it is a distributed computing model that has computation and storage closer to the location where it is needed. That is why it is called as an edge. To improve the response time and save bandwidth, this is like, if you have got huge amount of data coming in, you just assume like Hyderabad is there, it's a big city, how many LDCs would be there and how much of data will be generated. So if more amount of data is generated, you will require the bandwidth on which that data can be transmitted, which is not a possibility to have every time. So basically what we do is we reduce the information, we fine tune it and then send it. So that is where edge computing can come in. Now basically you cannot divide that cloud computing is only good or fog computing is good or edge computing is good. It depends on what is your requirement, how you are going to implement it. If it is vehicle management, you need to decide. Obviously, the cloud computing would be required, as well as you may require edge computing. Maybe fog computing may not come in that case. So, yeah, this is obviously we have covered this thing, and then there's another one where I have given a very brief, comparison. So in cloud, you have got a remote data center, whereas in fog, you have got a local network data, and edge is on the direct. But edge will not be that powerful. It cannot decide everything. You need to think this way also. Edge is like a small officer in place. If there is a big problem, it cannot decide the things. It has to go to the cloud anyhow. Can anybody tell me what is latency? Delay, right, delay. So delay would be highest in cloud, fog would be lower and lowest in the edge. Processing power highest because obviously cloud has got more resources and lowest in edge. Storage virtually unlimited, significant but limited, and edge will be obviously quite limited there. Response slow, faster, and fastest. So I'll conclude with the thing is like, IoT can be utilized optimally to manage these vehicles. Vehicle management is of EVs actually need to be explored a lot here. What I have told you, like, fuel level and all of it, if it comes to EV, you have to go to battery then. And probably the part would be different totally here because EVs may not be used for transportation. Transportation means like for material transfer. Within the city, it may be used. So that needs to be explored. In fact, it is still being worked on. IoT needs to be propagated as, anyways, this we can just leave it off. So the fundamental was, like, I tried to, in more than 2 hours, a little bit more than 2 hours, what my intention was to get you into the working of IoT, and to basically understand through some case study that how it can be actually implemented. So now we see that there is geotab is there, Monet is there, these are all sensors, these are all on the ground. Then from there the data would be collected through the IoT gateway and it would be uploaded onto the net. Once it is uploaded onto the net, then you have got enough amount of information. Then what you can do is you can analyze it, you can process it, and you can go ahead on it. If you go online, there are a lot of data sets available on this also. So for fleet management, not as IoT, but as fleet management itself, the data sets are available. So how it can be best managed? Y'all, today probably your lunch is there in visitors blog, same place yesterday where we had it, not where y'all had it, but where others had it, it is still there. But from tomorrow, it will be in Kalam Hall. So there's one guy from Sweden who has come in. He's moving, you can find him in the campus also. He works on traffic management again. So you can just interact with him also in this case, if you all are interested on talking on it, how they work on traffic management and how IoT can be used for that thing. So there are a lot of applications. I personally did not choose anything from CS and EC and electrical because it would be confined to understanding part. I took a very generalized topic where everybody could connect with it. So this would be all. If there are any questions, I'll take it. Okay. So a little bit from my side. These are 3 books which I have done. The last one is from a conference. The second one is edited one. The first one is self-authored. And this is one of the upcoming conferences on which we are working on. This is to be conducted in NIT Srinagar. The call for papers is open now. This is the second conference that we are conducting there. Thank you. If there are anything else that we need to discuss, we'll have it. Otherwise, we'll proceed for lunch. And the next session would be in electrical department. That's it. Coming with you all for lunch as well, and they will help you come to we can discuss amongst ourselves. Don't stick to your seat. If you want to move around in the hall, most welcome. Let us talk to each other and understand how it works, because it's not a class that we are attending, it's an FDP, so we should be in a position to make good connections, talk to each other also, learn from others. So initial maybe 10-15 minutes I'll just take to get it used to Arduino, that's it. And then what we will do is, I have got the Arduino board here. If somebody wants to come and see, they can see how it works, and how we connect it also, I'll show it to you. Other than that, if you already know all those things, then it does not make sense wasting time. What we will do is, we'll try to get some experiments done here and take up some example and try to solve it. And the condition is very simple. You can solve by talking to each other, by using internet, whatever sources you want to use, you use it. And let me again repeat it. This was like an added session that we have added into Arduino programming. This was not there initially. We have just done it because without Arduino programming, your IoT can work, but this is a great help. So Arduino is like a small microcontroller programming thing, which can be easily programmed through your laptop, and you can gather readings from different sensors in it in a very easy way. So it actually helps you into evolving different kinds of applications, real world applications, and see how it works. So I'll not go into the history of it and all of it, but let us just get a small introduction on Arduino programming and see how it works out. This is an open source platform. The website that you are seeing there, that side website is only for the picture. This side is the main website, that is arduino.cc, and I'll surf through that website and I'll show it to you that it is really very beneficial to utilize that website. Everything is available there. The best part is it is open source. That means you can also add coding to that. Now before I go into this thing, majority of us are from electrical, then we have CSE, ECE also. See, there are different ways and approach to an application when you actually go for an development of anything, there are different approaches to it. Like when I am into a freelance programming, what will happen is, my idea is to get an output, that's it. What kind of a code is there, what is inside it, I don't care, to be very frank, till the output is being reached. If the same thing is being done by a research scholar, it is totally different. He or she needs to know all the ins and out of that program, the algorithm of it, the flowchart of it, and so on forward. Now when we go for an application, which is a real world application and only software is not involved, then there are more aspects to it. Now when you are working on Arduino, one is you need to connect it with your laptop, program it, then you use it wherever you want to. The point is that, am I interested in the programming part? Am I interested in the construct of the Arduino board? Am I interested in what part of it? So is the construct going to change my programming in any way? Yes or no is the question that I need to ask. If it is not going to affect, maybe I can just leave it off. As a research scholar, you need to cover every part of it. Like if I'm working on a battery, it's a lithium ion battery, you need to know everything about it. How it charges, discharges, what is the chemical properties of it, what is SOC, what is SOH, what is this, what is that, whatever you want, everything has to be covered into that. On the other hand, here the point is that, in that, if I'm not using the hardware, it is okay. But if I'm using hardware, then I need to even know the weight of the battery. Without that, how can I work on to that? So there are different kinds of applications and different kinds of thought process into it, and the learning part also. So in Arduino, I'll say you need to decide whether you want to go into all aspects of it. As a research scholar, yes, you should do it. But still, do I need to go into the construct of it as to what this is, what that pin is, what is that, that should be known at least. But what is inside that chip, should I know? I'm not sure whether it is required or not. So if you just see here, there's a chip here, a big one, and then you have got a push button here. There is a USB kind of a thing, a kind of connector like this. So in that you give the power supply to it, and even the feeding of the code will be happening from there only. So that one is a different image. If you see here, this is Uno, and you have got a different kind of a connection here. The pins are up, which is not visible there. Probably the chip is missing, that big one, but a smaller chip is available, and so on and so forth. So if you see there, approximately similar structure, but a little bit different. So even we have got different kind of constructions for Uno as well. Ultimately, the fundamental is that if you want to make good interactive projects, you can utilize this particular thing. The benefits, as far as I have done it, I am not a master in it right now, but yes, I have done some programming and I have implemented it, so I have a taste of it at least. So what has happened is that it's simple, easy, compatible, cheap. If you don't know the rate, I'll tell you it comes at around 400 max. So it's a good cost at that. And if you add sensors and other things to that, sensors are hardly like below 100 rupees. So you can have a small project running without even going up to 1000 rupees. So in fact, yes, tomorrow also that ESP8266 that we'll see, the rate on Amazon is I think so 499. So 500 rupees, and plus you add some more material to that, you are running a project already. So that is one of the things. Cheap. Connectivity is really good. Replaceable, I'm not sure, and that is why I've written there not for all Arduino. As per my workout, you cannot just replace one board with another one in many of the cases, but in some of the cases, yes, we can do it. The voltage remains steady. You have got, anyways, the third last is not that important, but the second last is more so important for me. You have got a good community support. I'll show you the website also. It provides you with a lot of information onto that. In fact, all that you need to know is available on the website. So you don't need a teacher to teach you, right? And then I have not experienced this thing, but yes, in some cases, open source is really beneficial. So that is one part of it. Usually we have a constant voltage supply of 5 volt as far as I remember. But we can adjust the voltage levels using the different pins which are there. The pins are here. There is a set of pins here. These are the pins which will be used for interaction, and there is a set of pins here also. The different kinds of boards that we have in Arduino. Arduino is actually had started at a very low level, but now they have got a number of boards available with them. So I have tried to get a collection of as many as I could. The first one is Uno. This is the most popular one, and the microcontroller that you have is Atmega 328P, and number of digital pins, analog pins, clock speed, and ideal for simple projects and learning. So we have taken Arduino R3 itself here, but that has been a little bit different. It is different. This is Arduino Mega. This is designed for complex projects for high memory and pins. The chip also has changed. If you just see, it is 2560 now, and the number of pins and everything has changed except for your clock speed, right? It is suitable for robotics, IoT, and large scale projects. As a beginner, I would suggest, even if you take it as a hobby, it will hardly take you 1,000 rupees to start a hobby. That is worth it, and you can just experiment with it. And anyways, I'll tell you all the benefits one by one. So you will see that, once you get a knack of it, then you feel like your confidence also grows, and you feel like, yes, I can do more. then you can experiment some more things and implement it. So even if it is not useful in your projects and research, I would suggest at least give one hand to it and see what happens. At the maximum you will lose 1,000 rupees, that's it. And that too on the higher side, I am saying. So we were able to get, right now as I said, we were establishing a lab. We were able to get majority of the smaller elements at a very low cost. Sensors are hardly having some cost. The cables are low cost. And this is going to around 400 and this one that we have brought is around 410 rupees. So I assume that you can obviously give it a try any day. If not, you can, if you have children at home, you can help them run robotics on your own and you can show how it works. So to be very frank, I came across some of the projects in Python also, which my students had made, and they had created a whole robot in which the robot moves around and senses the objects automatically for what we say, autonomous driving kind of a thing. And that student is already developing that robot. Right now it requires some battery power, so it is wired. So he's looking into the option of having it unwired. Once it is unwired, he plans to put it as a firefighting robot. The robot size is this big, that's it. So it's an option that you have again. And then you have got an Arduino Nano also. It's very compact and friendly. And you have got, again, just a second. You have got Atmega 3 to 8P. The analog pins have gone down a little bit. But this is for like if you have space constraints, you can utilize this one. Then you have got an Arduino Micro. Don't go by the image size. I have expanded it. An actual thing, the pin and the board size will change. So here you have got a small size USB for, small size board for USB functionality. If you see, the Atmega thing has changed again. The clock speed has changed, and it's the application is a little bit different here. Let me also tell you, Arduino, the website is free. Everything is free. There are other companies also who make boards which are similar to Arduino. So you can use that also, not compulsorily that you go by this itself. You can change it also. And then this one is Arduino Leonardo. This is integrated USB communication thing. The Atmega is different. Your projects requiring human interface can utilize this one. And if you see, there's Leonardo already written here. There also the specification is given there, so you can just see it there when you buy it. Right now, the version of ID, I think so I can get an answer from you. No, full form of ID. Integrated Development Environment. So as far as I could see, it is 2.3.4 right now. It is free to download from Arduino, and you can get that software from there. And once you get it, then you can load it to your Arduino itself directly. So I could even find the source code also there. So just a second, I'll try to show you the website. So this is the website where you get the software. You can directly download it, and when you download it, you get a software. If you put it on your desktop, it will have this icon there automatically, right? So that will help you to load your program onto the Arduino board. That's it. So you can write the program and you can upload it into Arduino, right? And right now it is 2.3.4. I would suggest that you keep it updated with yourself, so that would be helpful for you. I'll come back to this slide website again. There are a lot of things in this website which we need to explore. Let us get back to the Yes, so what we have is in Arduino, program is called as a sketch, and it will be basically divided into two parts. One is setup and loop. Setup is which will be executed once. Whatever you want to execute once will be written in the setup part, and whatever you want to get it repeated again and again and again, you will write it into loop. That's it. So basically, whenever you want to upload it, you have to connect it. I'll show you that part also. So only two functions are allowed for you to write it. Let me open that also and show it to you. Just give me 1 minute. I'll open that also. So it will look like this when it starts. And this is how you write the code onto that. If you see here, you will find that there is a setup part here, right? And there is a loop. I am not able to see my own mouse. So here, if you see, there is a setup written here. So that is the function that will only execute once, and by default you get this program with you, and there is a loop written here which is to be repeated. Okay. So the next thing is you have got this very good thing called as functions. Yesterday only I added this thing because it suddenly struck me that functions are very important. If you don't know the construct as to how it will work, we will not be able to work out properly. So let me just click it. And the best part is you have got, just a second, let me zoom it off. Yes. So if you just see here, there are a lot of functions. I'll not go into the details of it. You can just explore it and see what is there for you. One is like digital read, one is digital write. Pin mode is there to set up the mode, whether the pin is input, output, and other things. So you have got math functions also for squaring, square root at the bottom if you see. And you have got analog read. So this is when you connect it with the system, automatically these things can be utilized for gathering of the data. So there is a lot of functions, not as much as other programming languages, but yes, enough for us to run. So just go by it. So you can explore this thing again. And if I go here, there is something called as variables also. I assume that you understand what is a variable. Variable is something that can change during the execution of the program. So you have got variables, and we constants means those which will not change. So in a program you can see that there is a high and a low. This is usually like when you have to get an output, you say a high. When you don't want a output, you say a low, and so on and so forth. So these are the variables and constants and other things also which are there, right? We know a little bit about byte, char, float. If you have gone through C, you already have some idea about that. And then you have a structure here. So I'll not go much into that, but if you just see, structure means like sketch is a program. Out of that you have got a loop and a setup, and other things are also there, like operators are there, and let us not go into much details. Structure means how what are the facilities to write a program. So you have got a control structure like break, continue, while is a loop, else is goes with if, return, and all of it. More so like, C, if you remember. And if you just go up here, it will also tell you something like, yes, the elements of Arduino C++ code. So I can utilize that as well. Another one is examples. I don't think it will run, but the problem is with the mouse. So again, examples is again from the same website. I'm not changing the website. The website is same. You get a lot of examples here. So you can just see how basically you can blink a LED. You have a fading LED. So, I would suggest that you first go through these examples. This will be very helpful for you as a startup kind of a thing. Then you can move ahead with the other things. And the last thing is, I don't know why it's not working. Yes, the last thing is the resources. I'll share this with you, and the link also will be there probably, so you can just go to that. And these are some PDFs which are available online directly. You can just click and go through it to learn. There is a forum also which is available on that same website, and the best part is you have got certification also available, so you can just explore that part. So that is as far as the one-way communication goes. We'll stop it here and let us go to the other part of it. Let us explore how we can learn, we can teach each other, and how we can benefit from our knowledges. So there is another website there that is called as Tinkercad. So I don't know why my laptop is giving problems. So what am I doing is I'm going to I have actually specially created 5 kind of programs, out of which 2 I will share with you, and 3 we will try to create it in the remaining 1.5 hour or 1 hour that we have. So we will try to create it from our own side. Only the question will be floated. You can talk, and by that time, like sir wanted to share some information, we can have that also, and whatever. So it would be an open stage, and as well as we can talk with each other, move around here and there, and get the thing done. Okay. So what we will do is we'll try to have a simpler one first. Once you get that one, then you go to the second one, and then to the third one. The third one that I will propose is a tougher one probably. we can have it at different levels of completion also. So we will see that thing. So in case if you don't want to invest even 1,000 rupees, this is a good option for you to learn. Now, I have already logged in. If you log in, you basically get 3 options here. One is a 3D thing, this is another one, and the circuits. We are interested into circuits right now. So I have just logged in into the circuits one. But should I give you like 5-10 minutes to, if you have, how many of you all don't have an account in Tinkercad? Like, so I'll just leave for 4-5 minutes and you can create an account in Tinkercad, and we'll again come back so that you are able to open circuits. Those who already have it can help others. It is actually, if you see, it's from Autodesk, which is AutoCAD. So you can even draw some 3D designs there for other things. be available there or not, but yes, the two are obviously available with examples. So usually we go with the simpler ones and the students do the harder ones. So I'll show you the simpler ones and then let us go to the harder ones and we'll see what can be done. So when you want to do a new one, you go to create. How many of y'all are using Tinkercad for the first time? What? Oh. Long back. So maybe the design might have changed. So you go to create and you have got circuits here. And you will get a new one here. The components are here. You can just drag it and put it, right? You can, the components are here, or you can even search it out here. So Uno and everything is available here. You have got this option of writing a code here. Okay, I did not have anything. I have not done anything, right? So this is how it will look. You can give the name and you have got the code here. Now, personally speaking, I don't feel like these blocks are good enough. If you are used to it, it is okay. Otherwise, I usually shift to text because I like to write it, the program my way. So I shifted to text. So if you just 2 minutes, if you have a look, I'll be able to show it to you how it works. So if you go and add this thing here, right, immediately this code will turn on. You go to the code and now you will get this kind of a thing. I tried it once for blinking of the LED. It was easy till then, but as you go into a complex question, it becomes tough to do the thing. So I just shifted it to text. So what you do is, here you have got a block written. You just click on block and then there is text available here. So it will ask you whether you want to do it or not. You just say, I'm not able to see, but whatever it is. You just say yes and you can shift it. And again you get those two parts, loop and setup. You can remove whatever is written there and you can write your own code. So I'll show you how to write the code also. And to save it, you have to give a name here. Otherwise it will give some random names. On the top left, you need to give the names. If you don't give the names, it's gone. Some random name will come in. So I will basically try to utilize what I have already done. And this was the first one that I had. You also have got a breadboard there. So you can use a breadboard also. But I would suggest that let us go slow, simple. Just get a this thing. I'll just change this. This is, I think so, 220 ohm. Right? So what I have done is, if everybody can just have a look, I'll show it to you. You can make it within minutes. If you don't know, if you already know it, no need to pay attention. So I have brought an Arduino Uno board and then I have connected it to ground. LED is there and a resistor is there. There is a reason for it having 220 ohms, which you need to have it. And what I have done is I have connected the LED short leg to ground, right? And the long leg to one of part of the resistance and the other one to D6, I think so. D8, sorry, D8. So that is it. Just make this much. You have to just click and drag, drop. Wires will automatically be created. That would be really good. Once this is done, just let me know. So I'll show you the code also then. So you can even set up a lab if you want based on this itself. Intercad. In order to see that whatever the required amount of voltage and current will flow, then only the LED will be continuously glowing. Okay? And if at all still you require some additional amount of intensity, LED to be illuminated with high voltage, then you may have to change and increase the amount of the resistance. Okay? For a longer operation, the shortest amount of the resistance value will be supported. But for a continuous operation, depending upon our own requirements, you may have to change for different type of resistance. Okay? And initially, here you have to look into what sort of a pin structures that you are going to have. Okay? Each and every pin is having a specific functionality. Not every pin will be used as an analog pin or a digital pin. These are the only analog pins, A0 to A05. These are the 6 analog pins that we have. So only whatever the analog type of sensors that you are going to connect, you can connect it over here. And when you are going to make use of a digital sensors, then you have to use the digital pins. And that too, when you are going to use the 0 and 1, you should not connect any sort of a sensor while you are programming the Arduino board using the USB cable. Why? Because the same TX and RX pins will be used for the controller when you are dumping the code into this particular board. So that is the preliminary precautions that we have to take care of. Initially, there should not be any sort of a connections that you will be establishing in the TX and RX pins.
Once the code has been dumped and still you want to make use of this TX and RX pins, then you can connect any sort of a sensor and you can make use of this particular pins as a normal digital pins which can act as both input pin as well as an output pin. Okay? And specifically, these pins we call them as PWM pins, pulse width modulation. Most of our air conditioners that we are using nowadays, we are calling them as inverter ACs. So why we require that pulse width means, in order to see that the stability of the signal is continuously existing with a low one single pulse, if at all the single pulse is having a larger width, then the amount of the high voltage value that it is going to persist in will be high. So for that reason only, when you are going to make use of any sort of a component, then you may have to use this particular PW pin in order to see that the width of the pulse, if at all it suits the sensor requirement, then only it can be fixed over there. Otherwise, we cannot fix it over there. Okay? And once again, here you are having power supply which is onboard power supply which can be powered with respect to this particular Arduino board itself for all the devices that you are going to connect. All the devices here we mean that the sensors that you are going to connect can be powered by using a own onboard power supply which you are having it as both 5 volts as well as 3.3 volts. That 3.3 volts, some sensors they are very much persistent to high voltages. They can't even support for up to 5 volts. So immediately those sensors whose power requirement is only for 3.3 volts, then we can make use of the 3.3 volts onboard power supply. And here you can support this particular Arduino board using 2 different power modules. One, making use of this particular USB cable which in itself, when you connect it to the system, it will work. Nextly, you can use an outbound adapter. Electrical adapter will be there, no? Just like we connected with our modems, network modems and all. So similarly, you can connect this particular power supply also over here, which will support up to 12 volts, not beyond 12 volts. Okay, and this component we call it as a voltage regulator. This voltage regulator, it will be consuming the 12 volts as a 9 volt, 12 volts as an input, and it will deliver 2 different output voltage values, which are calling it as 3.3 volts and 5 volts. So these are the 2 pins from which your 3 volts and 5.5 volts are coming into picture. Okay, sir? Please correct me if at all I am wrong.
No, going right.
And one more thing is, when you are going to make use of this particular power supply, why we are making the onboard power supply itself means, in order to see that whatever the voltage that is already rectified, that is properly filtered without having any ripples, all the sensor components that you are going to make use of can make use of the same supply and see that no particular filtering is further required, and the components will not fail in any of the cases. Okay? And this is the crystal oscillator which you are seeing across here. That SR told in that 16 megahertz crystal is there. No? This 16 megahertz crystal, why we require means is like that crystal clock is the synchronizing signal among all the sensors. Yes, sir. This one, this is the synchronizing signal that will be generated, which will be used by the controller as well as all the sensory components wherein you are to have a synchronization among all the components with respect to data delivery. Okay? And moreover, it has got an onboard LED which will be bringing out the digital I/O pin that will be 13th pin. Digital I/O pin is the 13th pin. And as said, this particular board is basically a DIP package. This sort of a lengthy IC that we are showing now, it is a DIP package, dual inline package. Okay, and there will be an onboard chip which short word there is a small rectangular one. That is a SMD component. So both you can make use and you can even develop your own board structure also. Okay. And what additional things that you may have to require? Basically, these are the things that you can try to work on, right? But if at all you want to have all these components removed and you just want to make use of this 328P IC only, then also you may have to use these 2 components specifically. Okay, I can design my own board without using any of these particular existing components on this particular chip and making use of only this and the voltage regulator, I can design my own board, my own layout, I can do whatever I want. That is what that open source means. That 328 pin component, that itself is the costliest of that particular controller board. Okay, it will be costing around 190 rupees if at all you want to purchase it outright, and if at all you want to buy it on a board, maximum you are spending is only 400 rupees. But this will be the rugged board. This is a very rugged board. You can make use of anything, any number of times. Okay. So you are showing that Arduino Mega board, sir. In your slide.
You want
Please.
Hey, just a second. Just one.
And basically, this jig tag is there, this one. There is a slight difference between the boards that you purchase outside. Some boards will be in blue color, some boards will be in green color,
Sir.
and some boards will be in red color. Yes. Some boards will be in red color. The fundamental difference between all these three boards are not only related to the controller or clock frequencies, but additionally the way we program it. Okay, the way they can operate with, the number of sensors that it can be connected with. And this is the Arduino Mega board. This is the Arduino Mega board. No? This is basically two Arduino ICs that are inbuilt with each other. Okay, so this will be having an overall of, in the initial board you have seen only one transmitter and one receiver. But here you will be having two transmitters and two receivers. The same board can be used for performing both transmission as well as the reception, which can be able to communicate with multiple devices. Multiple components can be interfaced. It can have a complexity of connecting a VGA graphics related device also on board, surface mounted. We can try to program it, we can try to make use of it for any of the application as if we do it in our normal desktop systems. But not that complexity, but some slight text related activities, if at all you want, you can try to generate it and make use of it as a computer. Okay, and here also, most of the fundamental pins that you are trying to see are one and the same. But additional pin configurations are used for supporting multiple type of devices, digital and analog. Okay? And buy it online. The one compact.
Actually, sir met me and said he wanted to share his knowledge about Arduino. Thank you very much, sir. And this is the spirit of the FDP, like, we interact with each other, we talk with each other, and that was really a great amount of knowledge that you shared. On a lighter note, you cannot keep a teacher away from the stage. So, yeah.
Regarding the pins, each and every pin, they will be generating only 20 milliamperes of current. That current is not quite sufficient for the LED also to glow. That will improve the current rating by using the 220 resistors.
So these are that is what I started with. These are two aspects of it. Like sir is more interested into the actual construct of it, and yeah, please. Sorry for that. The thing is like sir is more interested into the construct of it. There might be somebody else who may not be interested into that part, but more interested into the programming part of it only. So maybe I don't care what that thing is. I can just concentrate into programming. But again, I'll get back to it. If you are doing research, please do both part of it. So you should know the electronic part to the level that, like sir is telling you, at least if not to that level, some basic information should be there with us. And the other thing is programming obviously is what it is required. So the thing is 220, I'll give you the exact calculation also for that. I think so, if I had it somewhere, in the busyness I forgot it, but I have it, I'll share it with you. Why exactly 220, not 210, 230? Sir has already given the reason why it is required, but why that exactly 220, the calculation also is there for that. So sir, you actually added a very good color to the FDP, and I would also request, we still have 1 hour, if somebody wants to further share their, anyways, tomorrow also we can do the same thing. If you have some more information and things, and but just tell me beforehand, like sir had already told me that he wants to do it. So please do it, we are most welcome, and let us share our information that we have. Then what I have done is, I have written a code here for this thing, and it looks something like this. Is it visible? No. I'll just copy it. So, this is some issue with the projector, but I think so it is visible now. I'll still try to. I'm just increasing the size of the font. The size is there, no font. Oh, too big. But anyways, so this is C++ code. This is the pin mode. The pin mode is output. So it will send an output for that. Let us not go into much details, otherwise we'll lose a lot of time. And then you have got a digital write 8. This is pin number 8. This is pin number 8. High. High means it should glow. And a delay of 1000 milliseconds. Then again digital write at pin number 8 again, which we have set as output to low, and a delay of 1000. So this will lead us to a blinking of the light. So I believe, even if you don't complete the session today, the program that I give you for the last one, you can try it at your rooms somewhere. So are we getting the output then? I'll just run it. And you can see that it is blinking. Right, simple. Actually, I would suggest you can set up a full lab on this. 3, 4, 5, 8 experiments can easily be set up with no issues into that. Especially in electronics, you can easily have it. So one done. One more, I'll show it to you, then it goes up to you to do the remaining part. Aish. Aish. So in this one, what we have done is we are going with a street light design kind of a thing. The only problem is again the visibility. So I'll just try to see whether it is visible or not. I'll try to go there and show it to you. What I've done is I've got 3 LEDs now, red, yellow and green. And this example is also available there in the example section, but I've just made it again. So what we have done is, you have got a ground pin here, and in breadboard what happens is these are vertical connections, these are horizontal connections, these two. So I have connected ground here, and then the resistances are connected here. Then they go here again and they are connected to the LED, and then they go to different pins. The pins that I have taken is 8, 10 and 12. So 8, 10 and 12. Sorry, 8, 10 and 12. Then on the other side it goes to the resistor and then it goes to the ground. That's it.
Voltage signal is directly applied to the LED first before resistor.
It should not happen, but it's working right now. It should not happen. It should be the reverse.
Sir, it is actually presented in the center point of both the LED and DC. So naturally the resistance will itself observe as a part.
It will, but what sir is saying is also correct. It should have been that side, but right now it is working. Sure. As I said, I'm more interested into the coding side, whether it is working or not. So was made in a, so I knew there was a mistake there. So what you have here is again in the setup. This is actually in the setup. I have put pin 12, 10 and 8 as output, and I write it as one as high, others as low. Then I go for a delay. Then again the second one is high, the remaining 2 as low, again delay, and that is how it works. There is one more issue actually, I think so. If I don't get it wrong, I have put 220 kilo ohm. The blinking is very light in this. This is how it looks. It's like red, yellow, green. Again, red, yellow, green. You can also choose orange, and there are different LEDs which are there. So in the next part, this is all from my side that I'll speak. Now we'll be solving something more. So once you have completed it, I'll get back to it. But let us go for the first one. At least you can hear me out, and then you can try it on your own. Use whatever facilities you have with you, your friends, ChatGPT, this, that, whatever it is, use it. But once you have done it, again I'll repeat, either you should know the flow of the program, or you should at least know the construct of the things, and if both are known, then that is very good. So the next thing is, I want you to use a potentiometer to control the illumination level of the LED. There is a potentiometer there. Use a potentiometer, only one LED, and you need to control it. And these are the three questions that we'll try to address after you have done all the experiments from your side. And in between you'll have tea as well. You sit there only, you can, like ma'am is using, you can give her a connection as well. You can give her a connection as well, and you can also sit. उसमें चार है. You can create more solutions and more questions. Because of lack of time, I have just given. I assume that majority of you all might not be knowing it. So try it out. Other things as well. This is just to ignite your mind to do some different things. That's it. So even if it helps like 5-10 people to improve it, it's very good. Those who know it already, you can further explore to create newer questions on that. And by that time, I'll again leave the stage open. If somebody has got some good information about it, please do try. If you have finished two, you can tell me the third. I'll explain it to you. What exactly it is. But or otherwise, you first try the first two, then how to and then further.
you.